What you didn't know about iodine but could save your life. Of all the elements known so far to be essential for human health, iodine is easily the most misunderstood and the most feared. Yet iodine is the safest of all the essential trace elements. It is the only one that can be administered safely for long periods of time in high doses, as long as one understands the basics of this treatment and knows how to adapt the dose to his or her needs. Every individual is unique, so everyone will have different requirements in regards to iodine or cofactors. But how much iodine do we really need? And is it necessary to supplement this trace element at all? For over 100 years, iodine has been known as a necessary element for the production of thyroid hormone. However, iodine is needed in every single of the trillions of cells in our body, a fact rarely mentioned in the medical literature. Iodine is necessary in the production of other hormones in the body, for a functioning immune system, and has been shown to be a potent antibacterial, antiparasitic, antiviral, and anti-cancer agent, with no signs of resistance ever observed. Without iodine, no life is possible. Iodine deficiency can result in mental retardation, goiter, increased child and infant mortality, and infertility. Why then are we deficient in iodine? One of the reasons is the already mentioned poor availability of iodine in table salt, as well as a declining salt intake by the population due to health concerns, which for unrefined salt are entirely misguided. Another reason is that poor farming techniques have led to widespread deficiencies in soil minerals, amongst others of iodine. Exposure to many chemicals that inhibit iodine binding in the body further worsens the problem. However, the most significant change in iodine status of recent times occurred with a change in the food industry. In the 1960s, iodine was added to flour as a dough conditioner, but 10 years later, iodine was replaced by bromine. Bromine is another halide, also called halogen, as are iodine, fluoride, chloride, and astatine. This is the periodic table of elements with the group of halides. All halides compete with one another for absorption and receptor binding in the body. Since iodine and bromine compete with one another for absorption and receptor binding, the body can only eliminate bromine if there is sufficient iodine available. If there are a lot of halides competing for the receptor, a surplus of iodine has to be provided to the body to displace bromine from the receptors. Bromine is a toxic substance that has no use in our body and binds to iodine receptors in the breast and is a known carcinogen. In contrast, iodine is known for its anti-cancer properties. Replacing iodine with bromine and flour made a bad situation worse. Iodine deficiency has accelerated, and it is now being competitively inhibited from binding to its own receptors. Unfortunately, bromine can not only be found in flour, but is used everywhere in industrially produced goods. As flame retardant, it can be found in textiles, carpets, mattresses, cars, electronics, and is also found in pesticides. The list goes on and on. Generally speaking, there are two different forms of iodine: iodide and elemental iodine. Elemental iodine is not very soluble in water, but a French physician by the name of Jean Lugolov found in 1829 that potassium iodide added to water increased the solubility of iodine. He started to treat his patients with Lugol solution 5%, which holds his name to this day. Today we know that different tissues respond differently to the two forms of iodine. The thyroid gland, for instance, primarily utilizes iodide, while breast tissue prefers iodine. The anti-cancer effect of iodine is mostly based on the iodine form, whereas the iodide form, the one available in table salt, is much less effective. This means that iodine sufficiency is best achieved when we use both iodine and iodide, as can be found in Lugol's solution. What does iodine exactly do in our cells. Iodide is transported into the cells via a transport molecule called the sodium iodide symporter, or NIS. After it enters the cell, iodide undergoes two important processes: oxidation and organification. Oxidation occurs through the interaction of hydrogen peroxide, or H2O2, with thioperoxidase, or TPO, and effectively transforms iodide to iodine. This step is very important for the body's ability to utilize iodide. If the production of hydrogen peroxide used for the oxidation of the iodide is not tightly controlled, it can lead to damage of the thyroid tissue and to the possibility of forming antibodies against thioperoxidase, a condition called Hashimoto's disease, the most prevalent form of hyperthyroidism or low thyroid function. One element crucial in this process is selenium, another trace element most of us are deficient in. The next step in the utilization of iodine is called organification, which means that iodine becomes part of cholesterol, fats, and proteins. While the RDA of iodine is sufficient to produce enough thyroid hormones, it takes about 100 times the RDA to produce proteins like delta-iodolactone, a key regulator of programmed cell death called apoptosis, and cellular growth, both implicated in the formation of cancer. For over 60 years, it has been known that iodine concentrates in and is secreted by the mammary gland. The breasts are one of the main storage sites for iodine and is necessary for the development and maintenance of normal breast tissue. It also is important to ensure adequate iodine levels in young women before they become pregnant, because the normal development of the fetus requires adequate amounts of iodine. In utero deficiency has been associated with a range of problems in children, including ADHD, lowered IQ, depression, poor height and bone maturation, and decreased neonatal survival rates. So how much iodine do we have to provide to our bodies every day for its optimal health? Clearly, the RDA and even multiples of that seem dreadfully inadequate. One of the world's leading iodine researchers, the late Dr. Guy Abraham, has shown that the required daily intake of iodine necessary for maintaining adequate iodine levels is at least 13 milligrams, the equivalent of slightly less than 100 times the RDA. If you have a massive halide toxicity problem, or if you're suffering from chronic disease like cancer, thyroid problems, autoimmune disease, or chronic infections like Lyme disease, you might need substantially more than that. The following protocol is a suggestion on how to ingest iodine and cofactors which will help control symptoms of bromine toxicity once you start to dislodge that from the receptors. A crucial first step is adequate hydration. Make sure to drink non-fluoridated water, either by using a distiller or by reverse osmosis. First thing in the morning, we recommend to drink a glass of warm water with approximately half a teaspoon of unrefined salt to help the body get rid of halides. With your breakfast, take 1 drop of 5% Lugol diluted in water. You might want to add a few drops of apple cider vinegar to increase the taste. The dose of Lugols can slowly be increased over the next few weeks to reach anything between 4 to 8 drops per day. As a rule, overweight people require more iodine. 1 drop of 5% Lugols is the equivalent of 6.25 milligrams of iodine. If you struggle to ingest Lugol solution diluted in water, an alternative are tablets called Iodoral, which come in 12.5 milligram strength. The downside is that they are rather expensive. If you increase the dose too fast, you might experience signs of bromide toxicity, such as fatigue, muscle aches, runny nose, fever, diarrhea, and brain fog, among others. If that happens, simply skip the iodine for 2 days and resume ingestion at a lower dose. You will have to titrate the dose to the requirements of your body. If you skip the iodine, be sure to continue all the other measures to help detoxify your body. With the iodine, take selenium. Do not exceed 200 micrograms per day. If you suffer from chronic medical problems, it is advisable to take other cofactors to aid the body coping with the stress of detoxification. 100 milligrams of vitamin B2 and 500 milligrams of vitamin B3 can make a world of difference in such situations. Vitamin C is another valuable cofactor, but it should not be ingested at the same time as iodine, as the two partially neutralize each other. Wait for 2 hours after ingestion of the iodine before taking vitamin C. In general, a dose of 2 to 4 grams per day seems adequate. In the evening or late afternoon, have another glass of warm, salty water to aid detoxification. And you might want to take some magnesium before going to bed, preferably some chelated form like magnesium glycinate or magnesium malate. Many concerns have been voiced, chiefly among the medical establishment, about the safety of iodine, or the lack of it. One of the concerns heard most often is that high doses of iodine might induce hypothyroidism, the low functioning of the thyroid gland. Dr. Brownstein, a leading authority on iodine and author of the seminal book, Iodine: Why You Need It, Why You Can't Live Without It, has treated thousands of patients with iodine, and this problem has been very rare. Do children need iodine as well? The short answer is yes. For children to have adequate iodine levels is even more important, especially in regard to brain development. However, their dose needs to be adjusted to their age and weight. Once you start using Lugol solution, you will be amazed at the effects it will have on your body and your mind. It might take a bit of fine-tuning, but it's well worth the effort.